all the bits are independent to each other. That means I'm not going to depend on this ciphertext. What is the output I'm going to get from the key generation algorithm? That is the input to this XOR operation. RC4 is a symmetric byte-oriented stream cipher with variable length key size. Hello to all, a warm welcome to my new session on modern block cipher. I'm Revati from the Department of Computer Science, Vidhyaashram, First Grade College, Temple of Excellence, MYSURU. So dear student, before going to start my today's session, at the beginning, let me to recall the topic which I have covered in my previous session of this unit. I started with what is electronic code book, that is ECB, what is the application and what are the advantages we discussed. Along with that, I covered cipher block chaining, that is CBC and cipher feedback. These are the topic I have covered in my last session. But in my today's session, I'm going to deal with output feedback mode, that is OFB. Along with that, I'm going to deal with OFB as a stream cipher. Along with that, I'm going to deal with RC4 and A5 bar 1. So these are the topic I'm going to deal in my today's session. So dear student, let's begin with the topic output feedback mode or OFB. So in this mode, each bit in the ciphertext independent of previous bit. That means here all the ciphertexts are independent to previous bits. This avoids error propagation. That means all the bits are independent to each other. That means I'm not going to depend on this ciphertext. That is the advantage of output feedback mode. That means that reduces error propagation. So here this is the diagram for output feedback mode, and I'm going to have the parameters like encryption, plain text block, secret key, decryption, ciphertext, initial vector, then shift register and temporary register. These are the parameters I want to consider. Now, at the beginning, I'm going to have the initial vector, and this is the input to the encryption algorithm. Now, after applying encryption algorithm, whatever the output I'm going to get, that is divided into two parts, that is left shift register and right shift register, and I'm going to consider only left shift register. Okay, then this is the input to the XOR operation with the plain text. Now, whatever the output I'm going to get after performing XOR operation, that is the input to the next block. So here once again I'm going to perform encryption algorithm. The output is further divided into two parts, that is left shift register and right shift register, and I'm going to consider only the left shift register, and whatever the output I'm going to get from the left shift register, this is the input to the XOR operation. Now perform the XOR operation, and this is going to continue till end block. This is the way output feedback mode is works. So here see, this is the output, and this output is given to the input to the next block is known as output feedback mode. And same output feedback mode is also used as stream cipher. So here, see here, same key generation algorithm. So what is the input, that is n bit, and that is the input to the encryption algorithm. Now perform encryption algorithm with the help of key and get the output, and the output is further divided into left shift register and right shift register, and I'm going to consider only the left shift register, and that is the input to my XOR operation. And after performing XOR operation, whatever the output I'm going to get, I'm going to send that output to the insecure channel to receiver, and at the receiver side once again I'm going to apply key generation algorithm in order to get the plain text. So this is the way the output feedback as a stream cipher can be used. Now I'm going to have counter mode, that is CTR, that is counter mode. So here see, in each block I'm going to have the counter. See, instead of having plain text or instead of taking input from previous block, I'm going to have the counter, and this counter is going to vary from one block to another. In the counter mode, there is no feedback. See here, there is no feedback. Instead of that, what I'm going to do? I'm going to use the counter, and this pseudo randomness is the key stream is to achieved using counter. That means here I'm going to use pseudo random function in order to achieve the counter. Now I'm going to have the parameters like encrypt E, P plain text, K is nothing but secret key, initialize vector, C is nothing but ciphertext, K is nothing but encryption key. Okay, now I'm going to have the plain text, and that plain text is divided into number of blocks, and at the beginning what is my input? That is nothing but the initial vector, and this is the input to the encryption algorithm. After applying encryption algorithm, I'm going to get the ciphertext, and that is the input to the XOR operation with plain text. Now I'm going to get the output, that is n bits, that is nothing but the once again ciphertext. And if I consider next block, instead of initial vector I'm going to have the counter, and this is the input to next encryption function, and whatever the output I'm going to get from the encryption function, that is the input to the XOR operation with plain text 2. After that I'm going to get the ciphertext, and this is going to continue until I reach nth block. So here the counter is incremented for each block. So here each block, when I consider counter, the counter is going to increment from one block to another, and the same counter mode is used as a stream cipher. See here, same key generation algorithm. So I won't explain this key generation algorithm because I taught this one twice. So here I'm going to have key generation algorithm, and what is the output I'm going to get from the key generation algorithm? That is the input to this XOR operation. After performing XOR operation, I'm going to get the ciphertext that is sent to the receiver through the insecure channel. And at the end of receiver, once again we are going to apply decryption algorithm in order to get the ciphertext. This is the way the modern block ciphers are going to work. Now I'm going to have RC4. So dear student, let's see what is RC4, what is the need of RC4, and why we are going to use RC4, and what type of algorithm it is. So here, if I consider stream cipher is capable to take only one byte plain text. So what is one byte here? That is nothing but 8 bits, and especially it is going to take only binary numbers. Now this RC4 as well as A5 by 1 comes under stream cipher. That means these are the two type of algorithms comes under stream cipher, and this was developed by RSA lab, and this RC4 is also a symmetric byte oriented cipher. So it is symmetric byte oriented stream cipher with a variable length key. So here the length of the key is going to vary in which a byte. So what is one byte? That is nothing but 8 bits. That is nothing but 8 bits of plain text is exclusively ORed with a byte of key to produce a byte of ciphertext. So dear student, if I consider stream cipher, I'm going to have the plain text. And what is the length of the plain text? That is only 8 bits. Now I'm going to perform XOR operation with the plain text as well as key in order to get this ciphertext. And if I consider stream cipher, what is plain text length? That is 1 byte, that is nothing but 8 bits. And if I consider RC4, here RC4 algorithm is categorized into 2 types, or it is mainly divided into 2 parts. One is KSA, that is key scheduling algorithm, and another one is pseudo random generation algorithm. Key scheduling algorithm as well as pseudo random generation algorithm. And here RC4 algorithm is mainly based on the states. That means if I consider key scheduling algorithm, there I'm going to have the state. So the state ranges from 0 to 255. That is nothing but 256. So here RC4 is mainly based on the state, and state ranges from 0 to 255. Now I'm going to have the state and key initialization algorithm. See here, whatever the key I'm going to have, that includes states, and state ranges from 0 to 255, and I'm going to have the key. That means when my state length is 256, then my key size is also 256. Then I'm going to perform the initial permutation, and this initial permutation is done only once. That means I'm going to perform initial permutation only once. So here I'm going to have this state, that is 0 to 255, and I'm going to have the key, that is 0 to 255, and I'm going to perform mixed permutation. That means mix with key bytes and permute. That means I'm going to use to perform permutation with key as well as state. That means I want to shuffle both key and state. So this is the way the key scheduling algorithm is going to work. And if I consider pseudo random generation algorithm, once again it is mainly used to generate pseudo random numbers. And to generate my pseudo random numbers, I'm going to use pseudo random generation algorithm. This is all about RC4, and this RC4 is a symmetric byte oriented stream cipher with variable length key size. Now I'm going to have RC4, that is RC4 key scheduling algorithm. That means how I'm going to shuffle the keys. So start with an array S of numbers that ranges from 0 to 255. That means according to the state, I'm going to have the keys. So use key to truly shuffle S. Suppose if I want to shuffle S with key, I'm going to use key scheduling algorithm, and S forms internal state of the cipher. So here state is nothing but the internal state of the cipher, and which is responsible for give a key k of length L bytes. So here I'm going to have the key length L bytes. This is the way we can able to perform key generation algorithm in RC4. Now I'm going to have A5 bar 1. So this is also example for asymmetric key encryption, and this is also example for stream cipher. So dear student, if I consider A5 by 1, this is the member of the A5 family of cipher. If I consider A5 family, in that I'm going to have A5 bar 1, and this is used in global system of mobile communication. That means it is mainly used by GSM. So global system for mobile communication, and it is a mobile, that is network for mobile communication. So here it is network for mobile communication, and this is the overall representation of A5 by 1. So I'm going to have the key stream generator. This is the algorithm used to generate key, and what is the length of secret key? It is 64-bit. Okay, after that I'm going to have key stream buffer. So what is the size of key stream buffer? It is 228, that is 228 bits. Now I'm going to have the plain text. What is the length of plain text? Once again it is 228 bits, that is XORed with 28 bits. After performing XOR operation, I'm going to get 228 bits cipher text. Now let me to consider the diagram how the key generator is going to use. So here if I consider A5 bar 1 uses 3 left feedback shift register, that is nothing but the LFSR, that is nothing but linear or left. F is nothing but feedback shift register, and I'm going to have 3 shift register. And what's the length of each register? It is 19-bit, and here it is 22-bit, and here it is 3 bits. And what is the length of left feedback shift register? It is 64 bits. And all these red boxes are used to indicate clock. So clock synchronization. So here this all the red color box are used to indicate clock synchronization, and this is the majority function. Okay, now see here, if I consider 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, see here, whatever the 14th bit, I'm going to perform XOR operation, and 17th bit and 18th bit. So here I'm going to write it as function f of x4 XORed with f of x17 XORed with f of x18 and f of x19. That means to perform XOR operation, I'm going to use 19th bit, 18th bit, 17th bit as well as 14th bit. And what about my clock? It is 9th bit. And if I consider next shift register, once again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 and 22. So dear student, please remember the range here. Suppose if I start from 0, then 0 to 21. If I start with 1, 0 to 22. And if I start with 0, then my clock bit is 10. If I start with 1, then my clock bit is 11. And what are the XOR operation? That is f of x21 and f of x22 in terms of 1. And if I consider 0, then it is f of x20 XORed with f of x21. And if I consider last register, here it is once again 10. So I'm going to start from 0. It is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 and 22. So my clock is nothing but 10th position, and I'm going to perform XOR operation with 20th bit, 21st bit and 22nd bit. So here I'm going to have the equation, that is left feedback shift register of 1 is, I'm going to have the 19 bit in my first shift register, and I'm going to consider x of 19, x to the power 5 and x to the power 2 plus x plus 1. And if I consider second shift register, it is 22. And if I consider third shift register, it is 23. This is the way we can able to generate key in A5 by 1. So dear student, in my today's session, we started with output feedback mode and counter mode. Along with that, I covered RC4 as well as I covered A5 by 1, and these are the important topic from the examination point of view. And in my next session, I'm going to deal with Chinese remainder theorem, and this is also very important topic from the examination point of view. So dear student, let's meet in the next session with more information about Chinese remainder theorem. Until that, keep watching and keep learning. Take care. Thank you.